Our research team has been working on the applications and processing of PMU and synchrophasor data, I want to say, for about 5 years now. This paper presents a disturbance detection method based on the principal component analysis of PMU data. So just a little background, most disturbance detection methods require setting a reliable threshold, which is hard to obtain, or need data with high temporal resolution that increases the computational expenses. We noticed that the low-rank characteristics of synchrophasor data obtained from multiple locations of the electric grid can be exploited to detect outliers. We proposed a disturbance indicator measure using the principal component scores or PC scores of the data matrix, and also defined an analytical disturbance detection threshold that helps classify different events based on their severity. The method is low computational compared to other signal processing methods that use Fourier transformation or Kalman filter. So to explain the proposed method, given a tau by n data matrix where tau is the number of past samples and n is the number of PMUs, we can reconstruct the low-rank data using singular value decomposition. Sigmas are the singular values and u and v are the left and right singular vectors. We call the product of sigma and u the PC scores of data. We also notice that y tilde reconstructed only by the row first larger singular values is very close to y, with the Frobenius norm of their difference smaller than a threshold named alpha given by the norm of the noise. When a disturbance happens, the first PC scores change drastically. We use this fact to define a measure called delta t as the norm of the standard deviations of the first row PC scores. Then we propose a disturbance indicator called delta t tau p that compares the norm of the standard deviation of the current instant with a moment in the past. If the difference is large, we can conclude that there has been a large change in the signals. Then to distinguish disturbances, we propose a threshold beta using delta x, which is the average abrupt change we consider as disturbance and wish to detect. So looking at the disturbance detection algorithm, at each instant, we perform the singular value decomposition and we find rho, then calculate the corresponding PC scores. We calculate the disturbance indicator, then compare it with the predefined thresholds to detect and classify disturbances. Phi is the binary disturbance detection signal and is the output of the algorithm. The proposed method is tested on the IEEE 34 bus feeder with different scenarios. You can see that the proposed disturbance indicator not only works for large disturbances such as faults, shown on the left-hand side, but also for trivial disturbances such as those caused by the unload tap changer operation, shown on the right-hand side. The method is also robust against noise, and all the user must do is to set a proper threshold for different events they wish to detect. So in this paper, we showed that the low-rank properties of the synchrophasor data can be used to detect outliers. We defined a disturbance indicator using the PC scores of the data and also a proper analytical threshold for disturbance detection. The results show that the proposed algorithm can detect a variety of disturbances or events based on their severity and is robust against noise. Thank you very much.